Okay, good morning. Today we're going to talk about 7-7, which is writing exponential functions. Okay, the worksheet that I gave you has two sides to it. This is the front side. Okay, it has two examples. The first one is on population, and it has two questions. Okay, these two worksheets are actually part of the same worksheet, part of the same side. Okay, and then there are two questions. Okay, and then there's another example on investment. Okay, and then there are also two questions. Okay, so all four of these questions are on exponential growth. And then there are also questions on exponential decay. Okay, this is the back side. Okay, you can see because this is continued here. This is the back side of your worksheet, and it has this very nice table that allows you to compare the growth equation with the decay equation side by side. The growth equation basically says that whatever is the rate of growth, you're going to add that to 1, okay? And then that's going to be raised exponentially. And then if it's a decay, then it's 1 minus that rate. Okay, I hope you guys can see this on your paper. Okay. This is an example of a exponential decay question. Okay, they call it depreciation. You also see words like decrease. Okay, in your problem, those are all exponential decay questions. And there are two videos that you should have watched online that were from McGraw-Hill. Okay, and then there are three questions here. One's on population, one's on archaeology, and one's on depreciation. They are all depreciation questions or all exponential decay questions. Okay, so you will be using this formula. Okay, the one that's 1 minus the r. Okay, I am going to actually talk a little bit more about what's the difference. How do you use these equations? Okay, so here I'm going to do a little comparison between the growth questions and the decay questions. Okay, this is the general formula. This is the general equation. Y equals AB raised to the x. A is the original amount, okay, of your problem. Okay, Y is going to be the future amount after growth or after decay. Okay, so how do you, but this is the general one that describes an exponential behavior. The B is what determines whether or not it's a growth question or a decay question. If the B is greater than 1, then you're going to multiply the original amount by itself and then some more, right? So if the original amount was 100, and the B was, you had a growth rate of 20%. Then it becomes, you multiply it by itself, okay, and then plus the 20%, so it's 1.2. Okay, so that's how you're going to multiply this, 100 times 1.2. So every time you grow, you're going to grow by that 20%, okay, but you're also going to count that original amount. And then this x is the number of times that you're going to grow. So let's say that you were growing by 20% and you're going to grow that 5 times. Then this is going to be 5. If the question is one of decay and you start with 100 also, then you're going to have to multiply it by a number that's less than 1. Because if you multiply by less than 1, then it goes down in number. So let's say that you were decreasing or depreciating, okay, by 20% each time. Then you will end up with a 0.8, okay? And then if you were also, doing that over like 5 times, then this will be your exponent. Okay, so depending on this number, this B is what gives you the growth versus the decay. Now, when they put that into a growth question, this part, this 1 plus R part is the B. And then if you're dealing with a decay question, then that B would become a 1 minus R. Okay, so once again, let's backtrack a little bit. Let's recap that. So the Y is the future amount. A is the original amount. Okay. So if you will, the Y is going to be your answer, or the population later on after T number of years. Okay, usually it's in years, but not always, so you got to be careful about that one. So A is the original amount. In the example that we have, okay, which is this one on population growth, okay, The original amount was 25,000. The rate of growth was 3.2%. Now, when you put this into your equation, though, you cannot use 3.2. You got to convert that into a decimal. So it's 0.032. And then t is how many times does that amount grow? How many times does it, multiply? So in this case, they're talking about an annual growth. Okay, they're growing at an average rate of 3.2% per year. So it's an annual growth rate of 3.2. So you just have to count. If the rate that they give you is an annual growth rate, then the t would be measured in years as well. So let's compare. So I already did this part. Okay. I want to also talk about the how this relates to the interest. Okay, the amount of money in your investment. Okay, A represents the balance. That means how much money is in your account. Is equal to P, which is the principal. Principal means the original amount you invested, times, and then here this thing, okay, is like the B in the generic equation. Okay, so what they are doing here is this rate is an annual interest rate. And then they're dividing it by the number of times each year that this interest is going to compound. So if a bank pays you interest only once a year, then this will be 1. But if they compound it every month, then this will be a 12. Okay, but then you still have to, so if they do it like over 5 years, and then there are 12 times per year, so that's why the exponent becomes n times t, because that's the number of times that this thing has to increase. Okay, that this rate has to be like calculated. So this is very interesting because it's not just one thing, so in this case it's like 12 times a year times the number of years. Okay, if they say they're going to compound it every 2 weeks, then you would take 52 divided by 2 is 26. So this n then would become 26, and it will be 26 here as well, because the rate is always given in terms of an annual rate. Okay, and then this t is the number of years. Okay, so here's a question on exponential decay. You will use this formula, the a times 1 minus r raised to the t. There was a question that I think is especially hard because we've never done anything like this before. You probably have not come across it before, and it's a science question, and it's called, it's on half-lives. Okay, so what is a half-life? Okay, there are radioactive elements that are used for dating something that we dig up that's old, okay, based on the amount that is left in the, in the sample that we find. So let's say that something, okay, had an original concentration. Now this is an assumption, of course. We assume that it had this much, okay? That an original concentration of carbon-14 of 100 grams. That's the original amount, is 100 grams, okay? So if it has a half-life of 5,730 years, that means in 5,730 years, this amount would decrease by 50%. That's why it means half-life, because half of it will be gone. So this is something this is how you can think about half-life, okay? So half-life means it decreases by 50%. That means the R is going to be 0.5, okay? So if the half-life, say for example, okay, this is another example, it's not related to this one. Okay, let's say they tell you that the half-life of some element is 5 years. That means in 5 years, if you started out with 100, in 5 years you will have 50. In 10 years, which is another half-life later, you will have 25. And then another half-life later, you will have half of that, 12.5, and so on and so forth. And it would approach 0 but not reach 0. It could get to be a very small amount. Okay, but it will never get to 0. That's why we can use it to date something, to give something like an age. In this question that's in your homework, okay, the half-life is 5,730 years. that means in one cycle, we call that like it's one cycle. In one cycle, the amount is going to decrease by 50%. So in 2 cycles, it's going to decrease by another 50%. And the y then is calculated like this. Okay, the amount is going to be 100 is the starting point, and then you have 1 minus 0.5. And then t is the number of cycles you have. If it's this long of a period, then this t is only 1. If it's this long, okay, which is in the question, okay, after this much time, we're actually talking about just 2 cycles. This t then is 2. Okay, so that's basically how you do these questions. I don't know if that was enough. I will also post another video of how to solve this question. I mean, actually, this question is actually very simple. If they say, if the organism lived this long ago, what is the concentration of carbon-14 today? Okay, so that means it has gone through 1 cycle. So if you start out with 100, today it would be 50. And if it went through 2 cycles of the half-life, then what would be the concentration? It would be half of that, which is 25 grams. Okay, so in this question, you don't actually have to calculate it, you just have to understand the meaning of half-life and apply it this way. Okay, you started out with this much. Okay, I will do probably 1 question on another video so that you guys can see how it's done. I'll probably do 1 or 2 questions. Okay, but I hope that was helpful in getting you guys get started on your homework. Your homework, you should watch the videos to do the homework. If you don't watch the videos, it'll be very hard to do that. Or you have to study this carefully, okay? Study the questions, study the examples they give you, and that will help a great deal in solving these questions. Okay. All right, I'll talk to you a little later.